live? Yes. And we're back live. Give people an opportunity to get into the live stream. Stalling just so they can get in, get signed in, whatever they need to do. Okay. My objective for today is the same objective that I had last time. I knew this was going to take a couple of class periods, and I'm pretty much going to wrap it up today with the multiple choice inventory with what I wanted to do. So we are going to continue with that. Whatever you wrote your answers on last time, whatever you typed your answers into last time, obviously I want you to continue adding your answers to this multiple choice inventory. Again, this is not a grade that's going to count against you, but ultimately I am going to request to see which one, well, I'd like to see all your responses, you know, the abacadabra, whatever it is, and I want to know which ones you got right, which ones you got wrong. I'll make it very easy for you. I'll have a list of things, whatever, but you just need to keep organized and keep track of what you got right and what you got wrong as we're going through these problems. So let you get set up with that while people are filing into the chat. Thank you for the comments so far. Let me get this set up. Let's see here. So obviously you do have the calculator on your Chromebook if need be, because obviously some of these problems will require a calculator. A lot of them won't. But just in case you need to do any type of quick calculation, I just want to make sure that you had that thing going. Correct me if I'm wrong. We got through numbers 1 through 10 last time, right? Sweet. Okay. Just so you know, before we actually get started with these, number 14 on this, it's interesting. Number 14 on this, when I went back and actually looked at the results for the multiple choice on the AP test, they actually have a little star next to number 14. And I'm like, what's with the star next to number 14? And you'll see it when we get there. I'll show it to you. Actually, no, you can probably already see it. You have the PDF, which, you know, I'll remind you of where it is. But when you look at number 14, it's like, it's a question that they put on the AP test, but they did not count against anyone on the AP test. It was a question that I don't know if they threw it out. I don't know if it was like a test question in the sense of like, we're going to throw this question on there just to see how they deal with it, but then ultimately we're going to remove it. I don't know. I don't know what they were thinking. But just so you know, number 14 is not going to be a problem that we are actually going to answer. So let me flip my screen over. As a reminder, you do have this multiple choice in your Google Classroom. AP Stat, Google Classroom. If you go back to the 26th, there's the PDF with the multiple choice questions that you can utilize instead of looking at my screen, because my screen may not be the best in terms of quality to look at. I'll try to zoom in a little bit more. Wait, that's not zoom in. Oh, there it is. I want to type in 175. Whatever. Anyway. So we're going to pick up where we left off with number 11. The manager of a public swimming pool wants to compare the effectiveness of 2 laundry detergents, detergent A, detergent B, in cleaning the towels that are used daily. As each dirty towel is turned in, it is placed into the only washing machine on the premises. When the washing machine contains 20 towels, the manager flips a coin to determine whether detergent A or B will be used for that load. The cleanliness of the load of towels is rated on a scale of 1 to 10 by a person who does not know which detergent was used. The manager continues this experiment for many days. Which of the following best describes the manager's study? So take a few moments. I'm going to give you like maybe 30 seconds to 45 seconds or so to kind of determine what your answer should be. And then we'll talk about it. Remember this system. The system is you pick an answer that is your answer. Then I will give you the correct answer, and then you can keep track of if you got it right or if you got it wrong. There we go. Haha. Make sure you have an answer selected. Now, again, for this one, there's no calculations needed, obviously. As I said, a lot of them you have no calculations, just reading and then determining based on the context that they give you, like actually what the answer is. The correct answer to this one should have been A. It is a completely randomized design. And I want to talk about why that is in a moment. If this were a blocked design, then there would be some characteristic that you would block outside of the treatment. The treatment that's actually being put into place is which detergent that they're using to wash that particular load. But a randomized block design would be some kind of characteristic that you would block by, similar to that of stratified sampling, where you would separate the population into a characteristic and then sample a little bit from each. So this is not a randomized block design. I mean, there is ways of turning it into a randomized block design. I mean, if you had multiple washing machines, you could potentially do that. Or if you, I mean, and this is a public swimming pool, so I don't know. I'm trying to determine how could you actually like block it off. I don't know, if kids swimming versus adult swimming. I don't know. Something along those lines, something weird. Matched pair with detergent A and B. Matched pair is when you would take two, let's say participants, or experimental units, and they would go through the experiment, and then you would actually take each of them and compare them to each other. The best kind of example would be if you were running an experiment with married couples, and then the man and the woman went through the experiment, and then you were able to compare their results. In the end, that would be a matched pair design, and then you would actually find maybe the average of their differences. We're going to get back into matched pair designs with hypothesis testing soon. And this is definitely not an observational study. Definitely not, because there's a treatment. There is a treatment. There is a manipulation that's being put into place. This is an experiment. So answer's got to be A. There's nothing you can do about that. Oh, it's not scrolling. Why are you not scrolling? You should be scrolling. Click. There we go. Number 12. Oh, here we go. In the design of a survey, which of the following best explains how to minimize response bias? Ooh, response bias. It's been a while since you've heard that phrase. For those of you in the chat, I just in case, I copied and pasted the link to the PDF, just in case you didn't have it earlier. This, again, is probably one of those questions that reasonably should take you much less than 2 minutes. Much less than 2 minutes. At the same time, you don't want to rush through it. You don't just want to throw an answer up there and be like, that's got to be, I'm moving on. You got to give the problem its due diligence. Every multiple choice question, every single one, I want you to assume that other people are getting it correct. You have to assume that other people are getting it correct. And every correct answer that they get and that you don't get is one step down that ladder below that 40th percentile. Your job is to beat the bottom 40% of students who take this test. If you beat them, you will pass. The answer to this particular question should have been E. should have been E. Response bias is something within the design or the wording of the question that gears or pushes a person towards a certain response. Response bias would be possibly in the wording where they throw in some colorful language, or they try to tug on somebody's heartstrings in such a way in order to push them towards giving a certain answer of yes or no or what have you. So how do you minimize response bias? You have to carefully word and field test survey questions. It doesn't matter if you increase or decrease the sample size. That it should be randomly selected. Increase the number of questions? No. You have to make sure that your questions are worded carefully. That is how you minimize response bias. Number 13. For a sample of 42 rabbits, the mean weight is 5 pounds and the standard deviation is 3 pounds. Which of the following, and I want to emphasize this, is most likely true about the weights for the rabbits in the sample? I want you to note something for yourself. They use the phrase most likely true, implying that, well, you could argue more than one to be true. You could. Most likely to be true, the most true. Take some time, read the responses. I will give you a little bit more time to kind of read through these. Okay. Make sure you've selected an answer, because I'm going to walk you through a little bit of strategy for this problem. Words, 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 words. Lots of words. Okay. One thing I can definitely cross out, B. Definitely cross out B. It's approximately normal because the standard deviation is less than the mean. Like, it doesn't matter if the standard deviation is less than the mean. I mean, for the most part, the standard deviation in most real-life cases is less than the mean. That has nothing to do with whether or not it's normal. So I'm just going to cross that one out. Look at E. The distribution of weights has a median that is greater than the mean. This problem says nothing about the median. There's nothing in that statement that relates to anything that number 13 is trying to give you. So it leaves you with the following, A, C, and D. At the very least, if you were just going to guess from A, C, and D, you'd have a 33% chance. Which one might it be? Well, the answer to this particular question, just for the sake of argument, has to be C. And I want to talk about why. The answer is C. It says it's skewed to the right. Well, let me put the mean right in the middle without actually drawing this thing out just yet. It says that the standard deviation is 3 pounds. Well, if the standard deviation were 3 pounds And if we were to assume, let's say, a normal distribution, then 3 pounds would be 2 pounds. 2 standard deviations out would be -1 pounds. And all of a sudden, it's like, wait a minute. 2 standard deviations out, and I'm at -1 pounds? It doesn't really make much sense. No, it doesn't. It really doesn't. How is that even possible? But Mr. Markey, central limit theorem. The sample size is large enough. I know. But remember what the central limit theorem is talking about. The central limit theorem is talking about many means being put on a distribution. I don't know how many people are in this room right now, but counting the people in the chat, let's just assume it's over 20 people. You take a sample of 42 rabbits and get a mean. You take a sample of 42 rabbits and get a mean. You take a sample of 42 rabbits and take a mean. You take a sample of 42 rabbits and take a mean. I take a sample of 42 rabbits and take a mean. If we took all of our means and put them on some kind of a distribution, a histogram, what have you, the general shape then, yes, would look closer and closer to normal because of the central limit theorem. It is a distribution of means. And the larger the sample size that each of us individually take, the more and more normal that distribution would look. That's the central limit theorem. Part A is a perversion of the central limit theorem. Answer A is perverting the central limit theorem, trying to get you to think it's a nice answer, when in reality, there is just one sample of 42 rabbits being taken. It's just one sample of 42 rabbits. This thing is definitely skewed to the right. Because in reality, there we go. Most of your rabbits would have a mean weight. I don't know if this is where the mean would be. Actually, the mean would probably be pulled up a little bit. But the mean weight would be about 5 pounds in the actual distribution. You'd have your, overfed rabbits over here. And then clearly, actually, it wouldn't even be 0. I don't even know how big rabbits get or how small rabbits get. But you wouldn't have any rabbits that are like 0 pounds or something like that. So this is definitely more skewed to the right. I'm about to make fun of rabbits. Does anybody own a rabbit? No one minds if I make fun of rabbits? What is the purpose of owning a rabbit? I'm serious. They stay in a cage all day. You can't let them out of the cage. You have to change their poop constantly. What joy do they give you? Seriously. Just saying. I just wanted to get off my soapbox. My wife used to own a rabbit. Not when we were married. I wouldn't allow it. No, if she wanted a rabbit, I'd get her a rabbit. But I'd hate it. Oh, I would hate that rabbit. You know what's better? Cats. Don't shake your head. You know what cats do? Cats clean themselves. Cats take care of any type of bugs or rodents within the house. Just saying. Did I tell you about my cat and crickets? Okay, when cricket season rolls around, which it will soon, when cricket season rolls around in my house, you find random body parts of crickets. Because what my cat does is my cat hunts them in the middle of the night and lops off a limb and watches them crawl to their death. I'm not even kidding you. It's what he does. Back to this, number 14. Now, I mentioned number 14 was one of those questions that they actually dismissed. It's one of those questions where perhaps they found an error in the way that it was worded, or an error in the way that the responses were worded. In reality, they didn't tell me what the error was, and they didn't tell me what the answer was. On the answer key, it's literally just a star. So they I don't know if they gave everyone credit for 14 or if they just flat out excused it and had it all out of 39. So I'm just going to skip number 14. But actually, let's just read it for the sake of argument, just so you know. I'm not actually going to answer it, but when conducting a large sample test, null hypothesis, P equals P sub 0 for a single proportion, the test statistic is this, where P hat is the sample portion. Which of the following best explains the justification for the denominator of this test statistic? Oh, nice. Now, without actually answering the question, the denominator, that is the square root of PQ over N. They used P and Q because they were assuming a null hypothesis. That's interesting. Again, I don't know if there's like a wording problem. I don't know if there was a mistake that whoever made the question. So I'm hesitant to answer only because I don't want it to be like, ooh, there was a mistake somewhere that College Board didn't tell me about. Because like I said, they excused the question. So we're going to go number 15. Haha, lots of words. It's going to be fun. Number 15, a polling firm is interested in surveying a representative sample of registered voters in the United States. The firm has automated its sampling so that random phone numbers within the US are called. Each time a number is called, the procedure below is followed. If there is no response or if an answer machine is reached, another number is automatically called. If the person answers, the survey worker verifies that the person is at least 18 years of age. If the person is not at least 18 years of age, no response is recorded, another number is called. If the person is at least 18 years of age, that person is surveyed. Some people claim the procedure being used does not permit the results to be extended to all registered voters. Which of the following is not, and I'm very happy they put it in all capital letters, which of the following is not a legitimate concern about the procedure being used? I'll give you some time. Okay. Which of the following is not a concern, or I'm sorry, not a legitimate concern about the procedure, meaning that 4 of the choices are actually legitimate concerns? The answer to this problem is B. It should be B. Registered voters with unlisted phone numbers may be underrepresented in the sample. Well, that's not really a concern because they're sampling random phone numbers. The firm has automated its sampling so that random phone numbers within the US are called, implying that, well, they're just like randomly generating what the phone number is. And then, well, from there, it's like, yeah, I'll mark it off the list. We'll move on to the next one. Randomly generate, move it on the list, moving on. But for the rest of them, I just wanted to talk very briefly about why they're legitimate concerns. A, registered voters with children under the age of 18 may be underrepresented. Okay, there might be a little bit of a disconnect here. Is there, when you were a kid, did you answer your parents' cell phone? A lot of you shaking your head no. I think this is where the disconnect is kind of happening with this question, because this question came out in 2012. Back in the day, we used to have these phones that were connected to the wall through wires. You know what I'm talking? Okay. Back in the day, when the phone rang, it was everyone's in the household's responsibility to go get the phone if it was ringing, because we didn't know who it was. We didn't have caller ID. It just rang. And if you wanted to know who it was, you had to pick up and say hello, and then they had to explain who they were. This is how it was back in the day. So if the phone rang in my house when I was a kid, I would run up, pick up the phone, hello? And they'd be like, oh, hello, I'm so-and-so with blah, 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 blah. Are you over the age of 18? And I'd be like, no. They're like, okay, goodbye. All right, and then I'd hang up the phone. I mean, that didn't actually happen, but in this scenario, that's what they're really talking about. Now, in today's day and age, in the year 2021, if your cell phone rings, you're not running to go pick up your parents' cell phone. But in households back in the day, there was just one phone number that everyone shared as a family. So that's what it's really kind of getting to with part A right there. It's kind of an old style way of thinking about it. Oh, how times have changed. Goodness gracious. C, registered voters who have more than one telephone number may be overrepresented in this sample. Registered voters who have more than one telephone number. I mean, maybe that's a little bit of a concern, but how many people have more than one telephone number? Like drug dealers? I don't know. D, registered, there are people who have more than one, but there are not that many. There's not that many. Registered voters who live in households consisting of more than one voter may be underrepresented. Registered voters who live in households consisting, well, if it's a random sample, I mean, what are the chances, if it's a random sample, what are the chances that you would get two people from the same household in reality? I mean, maybe that's kind of a concern if you really think about it. But again, which of the following is not a legitimate concern? And then E, people who are not registered to vote may bias the sample results. People who are not registered to vote. Well, I mean, if they're not registered to vote, like I'm calling registered voters. So if they're not registered to vote, then they can't vote anyway. Yeah. That's where the answer's got to be B. It's the actual, not a legitimate concern. Unlisted phone numbers may be underrepresented. Well, no, I'm still going to get them. So, what a weird question. Scrolling down. Oh, here we go. A complex electronic device contains three components, A, B, and C. The probabilities of failure for each component are 0.01, 0.03, and 0.04 respectively. If any one component fails, the device will fail. If the components fail independently of one another, what is the probability that the device will not fail in 1 year? Go at it. This is one of those problems that is, and I'm going to choose my words very carefully, deceptively simple. Deceptively simple. It's deceptive in just the glorious way that they word it and stuff like that. And if you don't interpret the way that they word it, the way that they intended it to, if you don't interpret it correctly, then you're basically off in this wild goose chase just trying to guess an answer. But if you interpret it correctly, it's just like, oh my gosh, is that all they really wanted me to do? And the answer is yes. The key to this problem is the fact that each component fails independently of one another. Since they fail independently of one another, you don't have to jump through any major hoops to get this problem done. It's literally, okay, well, the first component, it's 0.01, a 1% chance of failing, which means a 99% chance of not failing. The second one has a 97% chance of not failing. And the third one has a 96% chance of not failing. Do I just multiply them together? Yes, you do. The answer is D. Yes. It's the first one not failing and the second one not failing and the third one not failing. Deceptively simple. Oh, you did? Oh, what'd you do? You added them and then subtracted from one?
Yeah, it doesn't give you the exact answer, but it's close.
Oh, I gotcha. That might just be flat out coincidence. Yeah, that might be flat out coincidence, though. That will not always work with every problem. This is the proper way of doing it. In fact, if you do this calculation correctly, what I just did, you actually get the number 0.921888, which obviously rounds to 0.922. Be careful, though, because like I said, on future questions, it may not just work out coincidentally like that. But again, I bring you back to a student I had a few years ago. Again, I'm not going to share the student's name. This student has long since graduated. This is a student that I was very concerned that the student was not going to do well on the AP test. And then when the scores came in, the student came in with a 3. And I'm like, whoa, how did that student get a 3? But I am granted access to analyzing their free response percentiles and their multiple choice percentiles. And this student, although they had great multiple choice skills, and here's the thing, if you accidentally get a multiple choice question correct, College Board doesn't care. You get it right. Because multiple choice, you don't have to back it up. You get it right, you get it right. But if you get it wrong, no credit. Sorry. You could at the very least guess. And if you guess and get it right, awesome. Good for you. What was someone trying to tell me the other day? Someone was trying to tell me the other day that they were taught that when in doubt, choose C. And I hate that statement so much. When in doubt, choose C. Are you kidding me? So I asked them, I'm like, well, what % of the time do you think that C is actually the answer? And they were kind of just dumbfounded for a second. And I'm like, well, if there are 4 choices, 25% of the time. Which means if you choose C, you have a 25% chance of being right, but you have a 75% chance of being wrong. When in doubt, choose C. Anyway, number 17. A large sample, 98% confidence interval for the proportion of hotel reservations that are canceled on the intended arrival day. That's a word. I don't even know what that is. It's a word thing. Is 0.048, 0.112. What is the point estimate for the proportion of hotel reservations that are canceled on the intended arrival day from which this interval was constructed? Now, it may seem like, what the heck are they even talking about here? I'm going to give you a moment to kind of figure this, to noodle this one out. these questions are designed in such a way, especially the first 20 questions, are designed in such a way to confuse and demoralize you. That is what the first 20 questions are intended for. They're intended to confuse and demoralize you because you're looking at this question and you're like, okay, hold on. I know what a 98% confidence interval is. You're dealing with proportions. I understand what that interval is actually saying. It's saying that I'm 98% confident that the true proportion of hotel reservations that are canceled on the arrival day is between 4.8% and 11.2%. Okay. What is the point estimate for the proportion of hotel reservations from which this interval was constructed? Let me ask you the question. If you are constructing a 98% confidence interval, what piece of data do you need? Let's say even in the calculator, what piece of data do you need to actually construct the interval? You know it's 98%, forget that for a moment. What other piece of data do you need? Let's see here. See if I can't bring this up. There we go. Where's my calculator? I left it up there like a jerk. If I'm going to construct a 98% confidence interval, and I'm going to go to one prop z int. Oh, look at that. The only other piece of information I need are x and n, which if I do x divided by n, that's p hat. That's all I need. That's all I need. I just need p hat. So I go back to the question. Hold on. Where's the question? There it is. What is the point estimate for the proportion of hotel reservations that are canceled on the intended arrival day from which this interval was constructed? If you have p hat, then you can also construct the standard error, the square root of p hat q hat over n. All you need is p hat. So if I just take these two and average them together, you get 0.08. That's the middle of the interval. Yes, the answer is C. It's again one of those questions where it's like, that's the most straightforward thing in the world, but why did they word it like that? Because they hate you. They do. The people who make this test want you to fail. You need to look through their garbage, take them by the throat and say, shut up, I'm going to pass. This test is violent. Also down with rabbits. Number 18. Number 18. Oh, by the way, just to be sure, because I didn't say the letter, 17 was C. 17 was C. I wrote the number, but I didn't say the letter. Now, this is one of those questions where I'm not really happy enough to say, hey, we're going to be able to do this one. We've spent maybe one day, maybe a day and a half, talking about t-testing. And t-testing, the rest of the way out, t-testing and chi-square testing, that's what we're really going to be focusing on after spring break through the end of April. And because the beginning of May, we do have a little bit of extra time in the beginning of the May because our test was pushed back a couple weeks. So I'm going to say for number 18 for now, we're going to skip number 18. You can give yourself like a little note, like not yet or some junk like that, because we're not there yet. We're not there yet. Yes, we've started T intervals and things of that nature, but one sample T procedures, we're not there yet. So I'm going to skip this one for now. Come on, number 19. Number 19, a nonprofit organization plans to hold a raffle to raise funds for its operations. A total of 1,000 raffle tickets will be sold for $1 each. After all the tickets are sold, one ticket will be selected at random, and its owner will receive $50. The expected value for the net gain for each ticket is negative 95 cents. What is the meaning of expected value in this context? Take a moment. Okay. Again, make sure you have an answer selected, keeping track of your rights and wrongs. When they say ticket owner, this is really weird to think about. When they say ticket owner, it's like literally the customer, like the person who purchased the ticket, the person who owns the ticket after they have purchased it, whatever, I don't know. But the expected value was calculated to be negative 95 cents. What that really means is that if I go to purchase a ticket and I participate in this raffle, then on average, for every ticket that I purchase, I am expected to lose about 95 cents. The answer is B. The answer is B. Now, it's interesting because C is saying something very similar. C is saying something very similar. B says the ticket owner loses an average of 95 cents per raffle ticket. And then C says each ticket owner will lose 95 cents per raffle ticket. They look incredibly similar to each other. But the key difference is using that phrase, an average of. Because basically, it's one of two categories. Either you lose $1 for purchasing the ticket, or you gain $49 for winning the raffle. And if you took the average of all those people of like -1, -1, -1, -1, -1, -1, -1, -1, and then the $49 gain by the one person, you average them together, well, 95 cents negative on average. Well, the ticket owner would have to purchase 19 more tickets for the expected value to gain. No, on average still, negative 95 cents per ticket on average. I mean, one of those tickets might be a winner, but ticket owner has a 95% chance. No, that has nothing to do with it. Yeah, the answer is B. Let's go to number 20. Oh, here we go. Oh, this is interesting. Okay, we can do this one. This one is kind of in the realm of like t-testing, but it is stuff that we have talked about. Suppose that on a hypothesis test for a single proportion mean, the alternate hypothesis is mu is less than 10. Suppose that the alternate hypothesis is true. For a fixed sample size and significance level alpha, the power of the test will be greatest if the actual mean is which of the following? Yeah, this is a weird way of putting it. I'm going to let you guys figure this one out. Take a shot at this one, and then I want to talk about what the power of a test is. Because again, that phrasing we haven't talked about maybe in like a month or so. want to see what you do first. Take a shot at it. Write down what you think the answer is, as we've done before, and then I want to explain a couple things about the power of a test. The power of a test is calculated as 1 minus beta. Beta being the chance of making a type 2 error. We don't know what beta is. We do know that beta can be changed depending on where alpha is. If we were to raise alpha, then beta would go down. And if beta goes down, then that raises the power of our test. Yes, absolutely. Alpha and beta have an inverse relationship. However, the problem says that alpha is fixed for a fixed significance level alpha, meaning you're not going to change alpha for this one. It's not going to change at all. Well, what's another way of changing the power of a test? Well, you could change the sample size. If you increase the sample size, then actually alpha and beta technically both get smaller if you increase that sample size, which would then increase the power of the test. Awesome, cool. But can't do that either because there's a fixed sample size. Oh. So I go back to a different definition. And this is very sneakily applying that definition. The definition of the power of the test. The power of the test, the power of a hypothesis test, is the test's ability to detect a false null hypothesis. Let me repeat that. The power of a test is the test's ability to detect a false null hypothesis. Mr. Markey, they don't give us the null hypothesis. I know they don't give us the null hypothesis, but we can assume that the null hypothesis is this based on the alternative. And the alternative is that mu is less than 10. If we want to increase the power of the test, which obviously we can't increase it now, they're basically saying the power of the test will be greatest if the actual mean is which of the following. Now, yes, we assume, based on the null hypothesis, we assume that the null is 10, but the alternative is looking, okay, we think it's less than 10. If we actually have enough evidence against the null hypothesis, we would reject the null hypothesis. Power of the test is the test's ability to detect a false null hypothesis. The answer is A. The answer is A. The reason why the answer is A, if the answer were A, if the actual true life mean were 8, and we ran this test not knowing that, the power of our test would be greatest. Because we would then have a very good power, a higher power, a greater power that would give us the ability to detect this false null hypothesis. Unfortunately, if the sample size and the alpha level are fixed, you can't control that. You can't control the power of that test. They're just basically saying the power of the test will be greatest if the actual mean was 8, not that you made it that. So if the actual mean was 8, meaning you had a lot of evidence against that 10, whatever that 10 is representing, then your power would be greatest. its ability to detect a false null hypothesis. It's a weird question, but it's utilizing a definition that we learned about a month ago in such a weird way. I love it. Number 21. Oh, this is amazing. Okay, so again, this is probably best that you have your computers for this one because all 5 choices aren't on the screen. Obviously, there's a 5th choice that's not on the screen, but I'll do my best to kind of show them. The residual plots from 5 different least squares regression lines are shown below. Which of the plots provides the strongest evidence that its regression line is an appropriate model for the data and is consistent with the assumptions required for inference for regression? Now, what's interesting is that the whole inference for regression thing we haven't done yet, but you can still answer this question. You can still answer this question. Let me just see what E looks like real quick. Heck yeah, there's E right there. So which of the following, which of the following plots provides the strongest evidence that the regression line is appropriate for the data and is consistent with the assumptions required for inference for regression? Yeah, this one's a little straightforward. But again, the way they word it, with the multiple choice questions that we've done so far, and this is more of a rhetorical question, but do you ever look at a multiple choice question and think to yourself, that seems too easy. There must be a trick? I'm just saying, yeah. Several of you are like, heck yeah. It seems too easy. Well, if I want the regression line, if I want the linear regression line to be appropriate, then my residual graph needs to be scattered. Yeah, the answer is C. The answer is C. It just seems like, what? You'd be surprised. You'd be very surprised. They'd put a question like that on the test, and there'd still be like 20, 25% of people getting it wrong. Because perhaps they second guessed themselves. Perhaps they did like my one student did a couple of years ago and took one for the team and just randomly answered questions and then took a nap. I swear to you that happened. Just raise your hand. No, don't do that. Anyway. Number 21 is C. 22, this will be the last one that we do today. A random sample of 50 students at a large high school resulted in a 95% confidence interval for the mean number of hours of sleep per day. 6.73 to 7.67. Which of the following statements best summarizes the meaning of this confidence interval? Perhaps we haven't constructed a confidence interval like this, but at the very least, we can talk about the meaning of said confidence interval. So, take some time, read it. Couple of things. I'm going to give you the answer, but then I have some expectations for the rest of this week, which I'll talk about. First of all, the answer is B. The answer is B. With the answer for B, they're actually getting more into the definition of what the 95% actually meant. The idea that if you were to conduct the sample many, many times of the similar sample size, 95% of those intervals would contain the true population mean. That's just what that 95% actually means there. So the answer is B. Now, pay attention to Google Classroom over the next couple of days. Now, obviously, I have you again on Thursday. But pay attention to Google Classroom over the next couple of days, because I may be throwing just a very, like, it's not even like an assessment. It's more like a kind of like a, hey, I need some information from you guys. One of the things that I may be throwing at you, I would like the results of what you've done so far. I would like the results of those multiple choice questions. But wait for the Google Classroom assignment, because I want all of the information in one concise location. So wait for that. Then I may be throwing at you, again, not a grade that would count against you, but I would throw at you the rest of the multiple choice questions just to give them a shot. Probably not all of them, because there are some in there that we have not covered yet. So I would tell you specifically which numbers to cover. So a couple of basic things like that, not an assessment that would count against you, but just more of like information finding and just giving you the proper practice that you can get done. Anyway, so yeah, I'll see you on Thursday. And then, like, well, Thursday is like a quote unquote half day, but you guys leave at normal time. Sucks to be you. I get to leave at 11:40. Ha 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 ha. Anyway, I'm gonna sign off. If you have not left a comment in the chat, I only see 4 comments in the chat. There's 7 people in there. If you haven't left a comment in the chat, I'll give you an opportunity to do that. Won't sign off just yet, but otherwise, I was 2 seconds early. There's the bell. See, I was 2 seconds early. What am I gonna do? Thank you, too. See ya. Down with rabbits. See ya. Bye. See ya. See ya. Have a good one.
Have a great day.
Thank you, too. See ya.
Have a nice day.
See you guys. Thank you. See ya.